This is a fairly common type of question that you'll see on the non-calculator paper. And what we're trying to work out or get from you is if you understand exactly what integration differentiation is. So you might be given several functions or graphs of these functions. So I'm just going to quickly draw in a few of these. Now they're not going to be quite to scale, but you get the idea. This is y, this is x. In fact, I'm going to put out the y-axis because obviously it depends on the type of function you're dealing with. If I had, say, this function here, there are some interesting points that we have. We have this point here. We're going to call this, by the way, we'll call this function, we're going to call this A. We'll call this one B. We'll call this one C. Those points are interesting, but not half as interesting is what this point here is. This is where the gradient is 0. Now, if we were to integrate that, that would be the derivative of the primitive. Okay, so if I was to differentiate it, I would need to know what this value here is, what this x value here is. Now, we've got a negative gradient, and I'll put that in. So we've got a negative gradient. All of this is negative. Then at this point here, and we're going to call this point, I don't know, we'll call this lambda. And then suddenly we have a positive gradient. Now let me put this onto this function here. Now we have this lambda that I was looking at, and this lambda is here. That's lambda. And we know we have a negative gradient, and a quadratic always differentiates to a linear function. Okay? And that's there. Now, so if I know from this definition, I know from this that C is the derivative of A. So if A is equal to f of x, C is equal to f prime of x. So how do we do for B? And remember, these can go in any orders really. So I know that I've got these 2 points here. I'll call that one alpha, I'll call this one beta. So we have alpha as one turning point location and beta as another turning point location. Now when we look at A and we go left of alpha, you can see that the gradient's positive. The gradient of the gradient function is negative, but the gradient of the original function is positive. That I understand that's difficult, but it goes positive gradient, positive gradient, positive gradient, positive gradient, positive gradient, and then there. Now it's very hard to draw this properly, but let's say it does something like this, and then at beta we have a negative gradient, negative gradient, negative gradient, then it's a turning, and then we have positive. Now let me see if I can highlight these for you. So this bit here corresponds to this bit here. This bit here corresponds to this bit here. and then finally this bit here corresponds to this bit here. And therefore we can say if a is equal to f of x, then d is equal to the integral of f of x dx. And if you, what am I talking about? B, not d, b. Or if we were to say if b is equal to f of x, you would have a is equal to f prime of x, and then c is equal to f prime, double prime of x, or the second derivative. That's very difficult to do, but you should always know that if it's a straight line, it's going to be the one that's been differentiated probably the most. What else should you know? If I was to look at a function like this, and I was given something like this, well, what do you know about that? If that's the gradient, by the way, of this is 0, so if the gradient is of this line is 0, this means this is going to be something like y is equal to minus 2. You would integrate that, and you would get something like, the integral of this would become something like y is equal to minus 2x plus the, okay, and then you'd have to integrate that again to get a curve, and integrate that again to get a cubic from the quadratic. But what if I said, what are the zeros? If I have some, let's have something really quite interesting. Let's have the sign, something like this. Let's do it like this. That was beautiful, isn't it? What are these? Oh, it's purple, let's go blue. What are these? We call these the zeros. And if this was the derivative, the zeros are what we call where we have the turning points only if this is the derivative. Okay.